The last type of equation that we're going to learn how to solve in section 2.4 comes in 2.4.3, solving rational equations. Now, in the previous section, we were talking about rational exponents, and we made an observation that the word rational contains the smaller word ratio. And remember, ratio means fraction. So in this case, we're not dealing with fractions in the exponent, we're dealing with fractions in the equation. So take a peek at these examples. All of these equations have fractions. We have dealt with equations with fractions in Unit 1, but we only had constants in the denominator. So in this section, we're going to learn how do we solve an equation that contains a fraction with a variable in the denominator. It will be related to what we learned about linear equations with constants in the denominator. So let's go through the algorithm or the process for solving a rational equation. Step 1, we're going to multiply all the terms in the equation by the lowest common denominator, LCD. LCD is lowest common denominator. So our goal, our first step, involves canceling the fractions. We're going to try and get rid of the fractions. And the way we do that is by multiplying each term by the lowest common denominator. Then we're going to reduce where possible. And step 2, solve the resulting equation. At that point, it may be linear, it may be quadratic. You'll have to assess the equation and then apply an appropriate set of steps. And then our last step is always check. Check by substitution, and that can be as simple as plugging it in and checking with your calculator. So let's give it a try. Example 3, solve the following equations exactly. We have a rational equation because I see a fraction in the first term, and it contains a variable in the denominator. So our goal is to multiply all of our terms by the lowest common denominator. Well, since there's only one denominator, our LCD is x plus 1. So I'm going to multiply each term in the original fraction by the LCD x plus 1. Now, I'm going to write it as x plus 1 over 1 so that it's compatible with the fraction that I have there. So the terms in blue are going to be the original terms of the equation, and the new red is the LCD being applied to those original terms. So every term, even on the right side, gets multiplied by the LCD times 0. I'm going to use parentheses for multiplication. Okay, let's go back and see what happens. Notice in the first term, the first fraction, the x plus 1 cancels because it's a like factor in the top and the bottom. And that leaves behind just a 6. Now, all of my fractions are gone. We have accomplished the goal to clear the fractions. Now, the next term I'm going to rearrange. Normally when we apply the distributive property, it feels more natural to have that little term on the left. So I'm going to move the 3 to the left. And on the right side, x plus 1 times 0 is just 0. On the next step, let's go ahead and distribute our negative 3 inside parentheses. So we have 6 minus 3x minus 3 equals 0. Now, if I asked you to classify or categorize this equation, what type of equation is this? Notice you have the variable x raised to the first power. I hope you recognize this is a linear equation. So we've gone from an equation containing a fraction after we cleared the fractions to a linear equation. And our goal, remember, in solving a linear equation is to isolate x. So let's combine our constants. 6 minus 3 gives me positive 3. Let's subtract 3 from both sides. And let's divide both sides by negative 3. When I divide by negative 3, what answer will I obtain? I hope you said x equals 1. Now, let's check it. I'm going to go back to the original equation, and I'm going to plug 1 in for x. So I have 6 divided by parentheses, 1 plus 1 close parentheses, minus 3. And we get a balanced equation. So x equals 1 is the correct answer. Let's try the next one. Since we have a rational equation, or an equation that contains fractions, our goal is to clear the fractions, right? Now, you can certainly get a common denominator and add the fractions as they are, but this seems to be a pretty simple method. The lowest common denominator in this case is the lowest common denominator between 2x and x, so I need a number that both of those denominators will evenly divide into, and that LCD is 2x. So I'm going to multiply all of the original terms from the equation by the LCD 2x. And when I run into a fraction, I'm going to write the LCD as 2x over 1. So I've got all of the original terms in blue, and you can see they've each received the lowest common denominator, which we decided was 2x. Now, let's cancel like factors. In the second factor here, the second product, the 2x's cancel. And on the right side of the equation, notice the x cancels, but the 2 is left behind. So let's go back and write our simplified equation. 2x times 1 is 2x minus, what's left here is the x minus 3. We definitely need to put that in a set of parentheses. And the same thing's going to be true over here. We have a constant 2 times a binomial x plus 1. So I'm going to have to intentionally insert those parentheses so that I can properly evaluate the distributive property. If I don't have those parentheses there, I'm going to have a hard time getting the right answer. So notice again at this point, after we have canceled all of the fractions, we have arrived at a linear equation. So our goal is to isolate x. So I'm going to distribute the negative here. We'll distribute the 2 on the right. Let's combine like terms on the left. 2x minus x is x. And now we're ready to start sorting our equation. We want to bring the variables to the left, so I'm going to subtract 2x from both sides. And let's bring our constants to the right, so I'm going to subtract 3 from both sides. And when we simplify, we get negative x equals negative 1. So what's the solution to this equation? X equals 1. Let's double check with our calculator to make sure we've done it correctly. So I'm going to type 1, I'm plugging 1 in for x in the original equation. But I do have to be careful with my syntax. Remember, anytime you have an operation in either your numerator or denominator, enclose it in parentheses when you type it into your calculator. So the left side gives us a value of 2. And the right side gives us a value of 2. So we have correctly solved that rational equation. Okay, let's go through a couple more for practice. Both of the first 2 examples led to linear equations. Let's see what happens on these. They're both rational, that is, they contain fractions. So my goal is to simplify the equation by canceling the fractions, and I'm going to do that with the LCD. The lowest common denominator in this case is not x, but x squared. It says lowest common denominator, but really it's the biggest of the 2 denominators. It's the lowest number that both of those denominators will evenly divide into. So you will see problems like this of the same pattern on your homework. Remember, your LCD is x squared. So let's multiply each of the original terms in the equation by the lowest common denominator, which is x squared. And when I run into a fraction, I'm going to write it as x squared over 1. And I'm even going to apply it over there on the right side where we have that 0. Okay, so again, the blue terms are the original terms from the equation, and they have each now received that red LCD x squared. Then we can go back and reduce where possible. In this second term, we can cancel one of the x's. I'm just going to write it like this. If I cancel an x into an x squared, that leaves behind an x in the top. And in this term, the x squareds cancel. So we end up with x squared times 1, which is x squared. Our second term, we have x times 2. We can write that as 2x. Minus 15 equals 0. Now, if I asked you to classify this equation, what type of equation is this? And your choices are linear, quadratic, radical, rational exponent, or rational. Those are the types of equations that we've learned how to solve. Hopefully you recognize this as a quadratic equation. Since it's quadratic, we've got 4 methods we can use to solve it. Factoring and quadratic formula are amongst those 4 methods. This one factors quite easily because we have a leading coefficient of 1. Notice our last sign here is negative. That tells me the signs in my binomial factors are going to be different. And the biggest one is going to be positive. So we need 2 factors of 15 with a difference of 2. And 5 and 3 would be the candidates that work. The biggest one has to be positive. So the factorization is x plus 5 times x minus 3 equals 0. Now, we set each factor equal to 0 and we solve for x. Can you tell me the solution that's going to come out of that first factor? Hopefully you said -5. What about the solution that comes out of that second factor? That should be x equals positive 3. Now remember, that comes from setting the factor equal to 0 and solving for x. And we've recognized the pattern here. If there's a plus in the factor, the answer turns out to be negative. If there's a negative in the factor, the answer turns out to be positive. Now, let's check to make sure that both of those work in the original equation. So I'm going to begin by checking -5. We have 1 plus 2 divided by -5 minus 15 divided by, be really careful here, I want to square -5. That means I need to put it in parentheses. So -5 balances the equation. Let's check 3. That one also balances the equation. So we have obtained 2 correct solutions for that equation. Let's try one last example for section 2.4, and this will be our last example for unit 2. So we have a rational equation. That means we have an equation that contains fractions. So our goal is to cancel the fractions using the LCD. What is the LCD for this equation? Hopefully you recognize it's the same pattern as the first example we did. So the lowest common denominator is x squared. So we need to multiply each term in the equation by x squared. All right, I've got all my original terms in blue, and they have each received the LCD x squared. Let's go back and reduce where we can. In my second term here, I can cancel one of those x's, leaving an x behind. And in that third term, the x squareds cancel. The result is the equation x squared minus x times 7, which we can write as 7x, plus 12 equals 0. Notice we again obtain a quadratic equation. So we can solve this very efficiently by factoring. Or if you prefer, you're welcome to do the quadratic formula. In this case, our 2 signs are going to be the same, and this one tells me they're both going to be negative. So we need 2 factors of 12 with a sum of 7. That would be 3 and 4. So the 2 solutions to this equation are x equals 3 and x equals 4. But let's be absolutely sure One of the things I love about math is usually you can devise a way to check your answer, and it's always a good idea to check your answer before the teacher checks it, right? So if you have a mistake, you can correct it. So I'm plugging 3 in for x in the original equation, and I get a balanced equation. And then I'll plug 4 in for x. And that one works as well. So both of our answers are correct. Okay, this completes section 2.4. It also completes unit 2. So once you have completed your homework, you can proceed to the test, and best of luck on the test.